miss. So quadratic functions, we've got the U-shaped graphs, right? And on these, all quadratic functions have what's called the axis of symmetry. It goes right down the middle of that U-shaped parabola. So that's called our axis of symmetry. And the vertex, if it opens up, the vertex will lie right there at the point HK as long as it's in vertex form. So HK is where our vertex is the vertex values there for H and K. If A is positive, if this number right here in front is positive, it will open up like it's shown here. This one's a U-shaped, it's open up. If it's negative, if that A is negative, then it's going to be U-shaped going down somehow, right? So let's use this vertex form and kind of analyze this axis of symmetry, the intercepts, and all that stuff for this equation here. So we've got y equals, let me write the vertex form here. Now, if I'm looking at this, the k is pretty easy to spot. K is 8, right? What's our h, though? -3. Good, good. Sometimes it's hard to see because you might, if it's a plus, you might write it like this because the h follows the minus. That's our h. H is -3. K here is +8. HK. That's our vertex. HK. Now, look at our A. Is the A positive or negative here? Yeah, I forgot. Oops. Yeah, negative there. Sorry, I forgot to write that in. A is negative. So A is negative. It's going to open which way? Down. Yeah, so let's go ahead. Let's put that point on there. -3, 8. And it's going to open down. And the axis of symmetry is right on that vertex. So that's the middle of the graph. I drew it in green there. Our axis of symmetry. And this opens down. So axis of symmetry is x equals h. Or in this case, x equals -3. Now, what we can do here, let's find some x-intercepts and y-intercepts. And I always like to just graph a few points. But we'll start with our intercepts here. So let's let y be 0. Subtract 8, both sides. Divide by -2. I have a perfect square, so I'm going to square root that. Plus or minus, since I square rooted both sides, and then I finally subtract 3. So I got -3 plus or minus 2. So I got -5 and -1. Those are where my x-intercepts are, right? So -5 and -1 is where I hit, right? Now let's find our y-intercept by letting x be 0. So we got -10. So when x is 0, y is -10. When x is 0, y is so like somewhere down here. So I can kind of draw this now. Ideally, I'm going to throw in maybe a few more points. I always like to, with my quadratics, I like to make a table of values as well with my vertex first. So here's my vertex. And then I like to go to the left a couple and the right of that a couple. Now we already actually got these, the x-intercepts we know are -5, 0, -1, 0. We already have those points on the graph right there in red. And we also have that point 0, -10 as well, don't we, from the y-intercept. But it's not a bad idea to throw a couple more in. You know, you could throw in -4. And just see where the y value is. So negative 1 squared is 1. 1 times negative 2 is negative 2 plus 8. So it ends up being 6. So negative 4, 6 right there. You could throw in negative 2. You're also going to get 6 because this is symmetrical about that axis of symmetry. And then you can draw it pretty good. All right. Opens down and so on. Okay. Any issues with that? Well, let's also talk about what's our domain here. Set of all x values. What's our x? What can we plug in for x? So I'm like looking this way. Do I have any restrictions left or right? No, so it's all real numbers. Now the range, on the other hand, what's the highest y value? 8. Yeah, so it goes up to that 8. So the range, we're going to say, well, from negative infinity up to 8. All right. All right, well, this is, so that was the vertex form. Now let's look at this. Here's our x squared plus bx plus c, our standard form, or, I'm sorry, oftentimes called the general form of a quadratic. If you were to complete the square on this, you could put it in vertex form, and then you could find what your axis of symmetry is from that. So you don't need to write this down, but let me just show it to you. If we were to complete the square, this is what it would look like. I push the c out. I take half of that b over a, take half of that, b over a, so b over 2a, and I'd square it. That's the number I'd put in, so b squared over 4a squared. So I added in a times b squared over 4a squared. In other words, b squared over 4a. So I'm going to subtract it from the same side. So I'm adding b squared over 4a, and I'm subtracting b squared over 4a. And now the reason I did that is so I could complete the square. This will actually factor into perfect square. Oops. Now let me write the vertex form below it. See how h is negative b over 2a? So that's the equation for the axis of symmetry, which is where the input is for the vertex. The axis of symmetry, when you're in this form, ax squared plus bx plus c, the axis of symmetry is negative b over 2a. Go ahead and memorize that if you have not seen that before. Okay, so here's our 3x squared plus bx plus c. Can you see how our a is 3, our b is 6, and our c is 1? You see that there? So let's plug it in. Okay, let's find our axis of symmetry. Negative, what's our b? What's our a? 3, right? So we got negative 6 over 6, which is negative 1. So this is saying that's our axis of symmetry. X equals negative 1, right? So the parabola is reflective about that line, x equals negative 1. So the vertex is somewhere on there. So I know my vertex has that input, negative 1. So it's negative 1 something. So I'm like, well, let me write my equation. 3x squared plus 6x plus 1. Let me throw in the negative 1. We got 3 minus 6, negative 3 plus 1, negative 2. So there it is, negative 1, negative 2. Now, last question. Does this thing open up or down? What's our a value? 3. Yeah, good. It opens up. Excellent. Excellent. So it opens up. And I didn't graph any other points, but I do know it kind of looks like that, right? We're not required to do anything else besides find that vertex. But I want to give you kind of a look on that. So let me pause this, have you guys try this one now. So you're given in this form. Go ahead, find the axis of symmetry, which will be the input for your vertex. Just go ahead, check yourself. X equals negative b over 2a. Should get that negative 5 force. Plug the negative 5 force into the original quadratic function. Get the 33/8. Now you know, I know it doesn't ask for a visual on this. It really just asks for the axis of symmetry on this. But I'll give you a visual here. We're at negative 1 1/4, and we're up 4 1/8, 33/8. So it's about right here. Our a value is negative, so this will open down, and our axis of symmetry goes right through x equals that vertex there, that x equals negative 5 force, right? Okay. All right, let's keep going here. Oh, let me go back to this for just a second. Sorry. This, notice it opens down. What do we call the highest value right there? Yeah, it's our vertex, and it's also our max value there, right? It's an absolute max right here. Whereas if it opens up, like this one right here, at this vertex, that one would be a what? Minimum. Yeah, that would be our minimum. So it matters. If it opens down, we have a what? Maximum. If it opens up, we have a minimum. So this one, it has an a that's negative 2. Is that going to have a max or a min? Minimum. Yeah, it's going to open down, right? I'm sorry, it opens down, so it has a maximum. I said that wrong. It has a maximum, right? So let's find it. Well, how do you find the maximum? Well, it's where at? Where is it at? On the vertex, and the vertex is on the axis of symmetry. Yeah, so the axis of symmetry, let's start with that. X equals negative b over 2a. Our b here is 8, 8x, right? Our a is that negative 2 in front. So we got 2. That's equaling 2 on this. So where's our vertex? Well, 2 something. So it looks like 11. 11, all right? So this hits at 2, 11. 2, 11. It opens down, right? So our max value is, what is our maximum value? Our maximum functional value. $11, yeah, that's the y value. It occurs at 2, yeah, that's how you say that. All right, let's go ahead and throw all this together again with our x squared minus 6x plus 5. Let's start out with our axis of symmetry. X equals negative b over 2a. Our b here is negative 6. Our a is 1. So we got 6 over 2. So we got x equaling 3. 1, 2, 3. There's our vertical axis of symmetry. Now we know the vertex has an input of 3. Get the y value, so it looks like negative 4. Notice our a is 1. Does it open up or down? Yeah. And then we'll do the x-intercept and the y-intercept next, but just make note, after you have this vertex, it's always good to go to the right a couple and to the left a couple. It's always nice, right? You'll see your parabola there. But let's go ahead and jump to our x-intercepts by letting y be 0. nice that this one does factor. So 1 and 5. In other words, 1, 0, and 5, 0. 1, 0, and 5, 0 are our x-intercepts, right? Our y-intercept, we got to let x be 0. So we have 0, 5. Throw that point on there. 0, 5. And that's really enough to graph it. Once you've got the vertex and a couple other points on both sides, that's enough. I mean, it'd be nice to throw in the 2. You know, if you throw the 2 in, 2 squared minus 6 times 2 plus 5. You have 4 minus 12, negative 8 plus 5, negative 3. So right there, and you could throw in the 4 as well if you want. If you want a couple more points, right? Make it a little nicer looking. Did you graph that thing? Any questions so far? You guys tried this one. And before we start it, what's your B here? 0. B is 0. Good. Go ahead and start that. All right, guys, let's go ahead and check yourselves. So start out with the axis of symmetry. Negative b over 2a, so it ends up being x equals 0. Now I plug that in, that 0 into the original, so y equals negative 5. So 0, negative 5, and I've got that point there in green, right? That's where the vertex is, which lies on the axis of symmetry. When I find the x-intercepts, it ends up being plus or minus root 5. Well, square root of 5 is about what as a decimal? Like square root of 4 is 2, right? Square root of 9 is 3. So it's like 2 point something, 2 and a little bit. Yeah, 2 point exactly. So like right here and right here. Does that make sense? But I don't have a nice integer coordinate. So let's go ahead and plug in maybe a couple more. Same thing with the y-intercept. Like I already have 0, negative 5 when I find the y-intercept. So let's plug in a few more. Let's throw 1 in. So y equals x squared minus 5. Let's throw in a 1, go to the right one. You got negative 4, so you're like, oh, that's 1, negative 4. Throw 2 in, 2 squared minus 5, that's negative 1, and so on. You could throw those in as well. Anyways, that gives you a couple more nice points for you. Oops, it's right there. Okay. And you're like, yeah, that's plenty. All right, kind of draw that thing. Should open up because my A is positive on that. Okay. All right, let's find what's wrong with this one given, first of all, before you start this. What's the issue with it, given equation? Yeah, so good. So let's throw it in order first. So you can recognize A, B, and C, right, before you do all that. Let me pause it and let you go through it. Well, let's go ahead and check yourselves here. So my axis of symmetry is x equals 2. I plotted that. I have my point 2, 2 from that input, x value of 2, right? Y output 2. Does this thing open up or down? Yeah, it opens up. Now, when I did to find the x-intercept, notice this, I let y be 0. It didn't factor. So I had to do it the old school quadratic formula, but it pops out the square root of negative 8. Well, that's not a real number. In other words, there's no x-intercepts. It never crosses. Why? Oh, because it goes up, right? This thing goes up. It opens up. And I did use that 0, 6 right there. Here's 0, 6. Which means it also has 4, 6. You could throw in some other points. I threw in like 1. Spit out 3. So you could throw in, I'm sorry, that's 3, 3. You could throw in 1, 3 as well. Right? Now let's talk about domain here. What's the domain for a quadratic? Left to right, do you have any restrictions? Yeah, all rails, exactly. Now how about the range? It's the lowest y value. 2, yeah, it goes from this 2 up, right? So there's your range on that thing. 2 to infinity. You guys good with that? All right, let's do a little bit of modeling now. So modeling, oh, and I should say this vertex here, is that a maximum or a minimum? Minimum, yeah. So the minimum value is 2. It occurs at x equals 2. So when you're modeling with quadratics, you're going to be involving those. You're going to be thinking about your minimums and maximums quite a bit. So for example, this one, you've got this height of an object. The height of an object is defined, and let me put it in with the negative 16t squared first. Let me put in this general form here with the t squared listed initially. Notice my a is negative, right? It's negative 16 there. So this, if you were to graph this thing, it's going to look something like that for time t and height h in feet. Time t in seconds. Right? For example, at time 0, if you plug 0 in for 0 in for t, sorry, you get height of 0. Right? Then it's going to blast up. This thing's a quadratic, opening down. It's going to blast up, and it's going to hit at some point. It's going to have a max height right there. Does that make sense? Well, where does the maximum occur on a quadratic? Can you say? That's right. It's right on that vertex, and the vertex is on the axis of symmetry. So we just got to find the axis of symmetry, and we'll know the time that it takes to hit that maximum height, right? So t equals negative b. In this case, our b is 512 over 2 times negative 16. So negative 512 divided by negative 32 ends up being 16 seconds. All right, so this is at 16 seconds. So 16 comma something. Now the question is, what's the height then? Well, the maximum occurs 16 comma something. Let's find the actual height. So 4,096, if you punch that in, go ahead and punch that in. Negative 16 times 16 squared plus 512 times 16. You should get 4,096 there. So that's our maximum height, right? So the max height is 4,096 feet, and it occurs after 16 seconds, right? Occurs after 16 seconds. Any issue with that? All right, let's go to this daily revenue now. So if you remember profit, your profit is your revenue, however much money you bring in, minus your costs, right? So if you're coming up with a profit function, you got to subtract the costs from the revenue. So let's do it for this one. Our revenue is given. It's 9.5x minus 0.04x squared minus our cost, which is, make sure you put that in parentheses because there's more than one term. Now combine those right there. So we got negative 0.04x squared. Let's see, what is that? 8.25x minus 250. Okay, here's our profit function. And x, by the way, is the number of boxes of candy you're selling, right? And we're trying to maximize our profit. So if you notice the A value is negative 0.04, this is another quadratic that opens down, right? We're trying to figure out like how many X boxes does it take to maximize profit, right? This is what we're looking at. And we're like, oh, well, once again, I just got to find my vertex, right? So axis of symmetry, here we go. Once again. So x equals negative b over 2a is our axis of symmetry. So negative, our b here is 8.25. And that ends up being 103.125. And we'll just go ahead and round that. Let's round. So we'll round that up to 104 for our vertex. So we have a whole number on that. And then we'll just throw it into our profit function. So the profit of 104 negative 0.04 times 104 squared plus 8.25 times 104 minus 250. And that ends up being 175.36. So if you sell 104 boxes, again, we rounded up on this, you'll get a nice profit, approximately nice profit of, exactly it's 103.125, right? But we'll just round up on this. So let's take a look at this. Among all pairs of numbers whose difference is 24, find a pair whose product is as small as possible. Pairs of numbers, the difference is 20. So let's let x and y be our numbers. So their difference is 24. And then their product, right, their product is what we're trying to minimize. We want a minimum product, the smallest number that they multiply to become. Does that make sense? What I'm going to do is I'm going to take this first one, I'm going to solve for y. Let's solve for x, I'm sorry. Let me add y. So I have x equals y plus 24. And then I'm going to go ahead and I'm going to substitute that in. Now y plus 24 is equal to x. So I'm going to plug it in right there. Let me multiply it through. So I have y squared plus 24y. And that's what I'm trying to minimize, right? It's a positive 1y squared. So it's going to look something like, something like this type of deal. And I'm trying to minimize, trying to find the minimum, right? We could have also done it in terms of x's, but we'll just leave it in terms of y's here. So what's our axis of symmetry? Well, in this case, it's a y is negative b over 2 times a. So we got negative 12 is our y. So we know y is negative 12, and I know x minus y is 24. Let's throw that in. Subtract 12 both sides, so x is 12. Okay, so our pair of numbers is 12 and negative 12. 12 and the y is negative 12. So what's the minimum product? Bless you. Well, the product is x times y. So it'd be 12 times negative 12. So it looks like the minimum product is negative 144 in this case. All right. or minimized it based on those two statements. Now this time we've got this river. Here's our river. And you've got 900 feet of fencing. You're wanting to enclose this rectangular field. And you're trying to maximize that area. Yeah, so I'm going to call this X, X, and Y. I want to maximize the area, but I only have 900 feet for the perimeter of fencing, right? So my perimeter here is what? Close, X plus Y. Yeah, adding up all the sides, right? That's total amount I have of fencing, X plus Y. And I know I only have 900 feet to do that with, right? So here's my first equation. Now we're trying to maximize the area that it encompasses. Well, what's the area of a rectangle? Good, length times width. So we got X times Y, right? That's what I'm trying to maximize. So what we're going to do is we're just going to go ahead and solve that for Y. That 900 equals 2x plus y, and then we'll substitute it into the other side. So we'll solve for y. So 900 equals 2x minus y, or plus y, sorry. Y equals 900 minus 2x. So this is going to go in for y right there. So our area equals x times 900 minus 2x. That's our y. So we got 900x minus 2x squared. Let me write that. Negative 2x squared plus 900x. All right, so here's our area. In other words, this is some quadratic that opens down, right? And I can find the x value that maximizes this now, if I find my axis of symmetry, right? So x equals negative b all over 2a. So negative 900 over negative 4 ends up being 225. So we want to have this x be 225. And then finally, so let me come over here. So I did this 1, 2, and now let me come over here 3. Whoops, this was 3 to find that. And now on number 4, then I know that x is 225. Y is 900 minus 2x. And so that ends up being 450. Right? And then lastly, it does ask us, what is the largest area? Well, we know x and y. I got 225 as x. Y is 450. Area is x times y. So, and I should say that's feet, so square feet. On that. Okay. So what we're going to do is we're going to say, well, we love this useful vertex form because it shows me my HK, right? What's our vertex here? Yeah, negative 1, 3. Yeah, okay, so we have HK. When we write the equation, so here's negative 1, here's 3. When we write this equation, we got to have A too. So the problem is we don't know what A is, but we can solve for A. So the question is, how can I solve for A? I have HK. What about XY? Where could I get an XY from? Point on the graph. Yeah, let's pick one. How about that y-intercept right there? 0, 5. There's a point on the graph, right? So let's use that 0, 5. So here's 0. Y is 5. So this is what we got. We got 5 equals A. 0 minus negative 1 squared plus 3. Now we just got to solve this for a. Subtract 3 both sides. So a ends up being 2. So now we have it. We know a is 2. And we have our vertex, hk. So y equals a, x minus h squared plus k, a, x minus negative 1 squared plus 3. And there it is.